Hello, everyone. Thank you for joining this talk. I'm looking forward to spending a few minutes talking about APIs. APIs is very much a passion of mine, and I'm excited to share with you a couple of key non-functional requirements that I think will give you a good baseline on our checklist, if you will, as you go to build your products and APIs as part of that. APIs are everywhere. You may have recognized APIs in using tools like Twitter or Dropbox or YouTube. Also, I would say that, using the cloud, if you've used the cloud with AWS or Azure or GCP, these products would not exist if it wasn't for APIs. So APIs are everywhere. There are actually companies that actually their whole product is an API. If you've worked with Stripe or Twilio, both of those use APIs as their product. And then there's also companies that actually connect APIs, and that's their product, is this integration between them. So, much of the internet today has to do with APIs. I imagine if you are starting a project that you will either need to interact with an API or think about making an API part of your product. So one of the things to think about, or what I think about when thinking about APIs, is APIs kind of describe the functionality of your application. To have a well-designed API is to have a well-defined application. So not only do APIs help other applications talk to your application, but I think it really serves as a guide or a structure of and a boundary of how your application is defined and how it should work in the world. A common high-level architecture is client server. So client server, you may have a browser or a mobile application, and then you may have a server or servers in the cloud or serverless. But this is the typical architecture of many, many applications. So we'll use this kind of to talk through today. And one of the things that you find out is that when you unpack kind of this server side, you will traditionally kind of branch into two layers at a very high level. You have kind of the API and your business logic in one layer, and then you have all of your services, which may be databases, maybe storage, maybe caching, SMS, emails, all of those things. Those are kind of the implementation details that you need to use for your product, but all the kind of special sauce that goes into your product that makes it different is really within this API application kind of layer. And the application is the front end to that. Now, that's just a very generalistic pattern. You can get much more detailed than that, but that's what we're going to talk through today. And we really want to talk about 5 requirements. And I call them kind of non-functional requirements because they're not specific to the functionality of your application, but these requirements actually do have a huge impact on the success of your API and your application. The first one we'll talk about today is security, and then we'll spend some time on documentation, and then we'll move to validation, which is something that's not talked about too often, but I'm going to really try to emphasize validation because I think it's a huge important piece. And then testing. Testing is common practice now in 2021. You want to write tests, but I'll try to provide some insight on how you might want to approach that with APIs. And then finally, monitoring, right? Being able to observe how your application and your API is performing. being able to make tweaks or enhancements and determine if that's enhancing the performance or actually causing problems, or really being able to track migrations. If you're moving from one, implementation detail to another, monitoring plays a huge role in that. And for this talk, we'll be mainly talking around REST JSON APIs. They're the most common APIs out there. But these requirements can really be used regardless of what kind of API implementation you use, whether it's REST or SOAP or gRPC or GraphQL. All of these requirements hold true for all of them, but we'll just talk in the context of REST. Great. So we'll go ahead and just jump on in because I'm really short on time, and for this talk is probably not going to be as entertaining as I would like it to be. I'm not super funny, but it will be informative. So we're going to cover a lot of ground, and just to let you know that I will have at the end of the talk a whole slide with a link to resources that can allow you to drive further into each one of these topics, because we're going to hit them at a high level and not necessarily be able to go deep into every one of them. But I'll give you some links which will allow you to get there. So the first topic is security. Security covers a lot of pieces, but some of the things we want to touch on is encryption, cores, authentication, and authorization. Obviously, security is super important in the world of software, especially when you're building software on the internet. You need to make sure that all of your API endpoints are HTTPS using SSL certificates. And there's a great nonprofit called let'sencrypt.org that can really help you through that process. Before Let's Encrypt, SSL certificates, and you can still buy them, but you would have to pay. With Let's Encrypt, you can actually register SSL certificates and configure them for your server for free. Now, there is another thing called cores, or cross-origin resource sharing. And this is when you're using browsers primarily as your client. And if your API is not of the same domain or the same origin, then the browser will ask your server for a policy to determine if this client-side domain has the right to access your API. And it's a very good policy. Sometimes it's a painful one to deal with because it's not enforced when you're going server to server, but primarily browser to server. And there's in many frameworks, there's a concept of middleware, and they have this cores middleware that you can plug in to set your policy for sharing. And it is pretty straightforward, and there's some great documentation on that. But one of the things of recent note in security is authentication. Authentication between this, kind of unsecured land of the internet into your very secured server has been a topic for many years. And one of the things I want to highlight is an option called a Json Web Token for you to really consider. A Json Web Token is a base 64 encoded token consisting of 3 parts. Part 1 is a header, and the header kind of tells you what kind of signature encryption is used to sign and what type it is, and just some basic information of the token. And then the payload is the middle piece. The payload gives you the data that your identity management server provides so that you can use that data to control how your API responds. And then finally, the signature. And the signature of the token is the algorithm that encrypts that, and it's not encrypted, it's base64 encoded, but the signature signs that. So when you go on the server in your API to validate a JSON Web Token, you can verify it based on that signature. And if it is true, then you know the contents of that token has not been changed since it was signed. And it's important for your application to sign those when you're in a secure environment. So your authentication server can sign that token, send it to an unsecure environment like the browser, and then you, your client can send that with the request, and your server can validate that request by checking your against either a secret or a public key, etc. So it's a really good way to make sure that the data that you're getting is the data that you're expecting. Another note on that is that you want anything in your payload to be okay to be viewed in public. You don't want to put secrets in here because if anyone is in the middle of your transactions, they could potentially see that information. So that's kind of authentication. And there's another side of security is called authorization. And with authorization, now that you've determined the identity of the request and verified that that identity is who they say they are, authorization determines if they're allowed to perform your API request or not. And that really comes in to fruition using scopes. Scopes are a way to define for a given resource and a given action if this particular request has the authority to execute, right? So you can break these scopes down with a resource followed by some sort of delimiter. Most use colons to delimit these, and then an action. So for example, if I did an asterisk colon asterisk, basically, if that is in my token, then this request has access to kind of everything. So you can think of the asterisk as all resources and the other asterisk as all actions, but you can be very specific, right? So that would be maybe a super user, but a traditional user may have, you know, this kind of space delimited string of resources and action combinations. In this case, let's suppose a movie reviewer application. And in the movie reviewer application, you have movie colon read, and that means the user can actually, you know, maybe search movies, list movies, view a particular movie. And then you have a resource review and write, and maybe that means the user can actually write a review or create a review or update a review. And then comment, delete, maybe they can't create comments, but they can actually delete comments. So that would be a way to specify scopes. And why it's important to think in scopes is to really determine how they associate with your users and your permission system. And here's just a couple of more scopes kind of grafted in a table where you have your resource, and then you have your actions, and then you have kind of a description of what all of these things do. And when you're implementing your API, then as you check and make sure your token is valid, then you look in the contents of the token and see a scope property. And that scope property would have all of the scopes that that particular request has the ability to do. And then you can determine that with your endpoint. If they're requesting to list movies, then they should have movie read in their scope. If they're wanting to delete a comment, they should have comment colon delete. And this allows your API to focus on functionality versus permissions management. That can be handled by a identity management platform. And the way that kind of works is you associate a given role with a set of scopes, and you could have multiple roles and multiple scopes connected to those roles. And here we have this movie reviewer role. So I can apply my user to this movie reviewer role, and they immediately get access to these scopes, which my API doesn't have to worry about knowing what a role is or what a user is per se. They just have to worry about what these scopes are. And for another example, we have review consumer, and that role may have like review read and comment create. So that's really what I wanted to touch on with security. There's a lot more, and there's a lot of resources, like I said, in the links that can kind of drill into that. But let's move to documentation. And documentation, there's 3 highlights that I want to hit, and think of these as kind of different points of view. So with documentation, you have kind of a README, and the README is kind of the point of the view of the contributor, someone who wants to maybe use your app, but also may want to contribute. So with your README, you know, describe your API, link to the documentation, but also provide how to set up as a developer, how to deploy any dependencies and how to manage those dependencies, a contribution guide, maybe link to a guide on how to do that, a license, a code of conduct, and gratitude. Always say thanks, as we heard this morning in the keynotes. You know, thanking your community is huge, and a README is a great place to do that. And then there's another type of documentation, which you know, kind of is your reference documentation or specifications. And this gets into the technical aspects of your API. How do I call it? How do I authenticate? What are the server URLs? What are the names of the endpoints, etc. And there's a specification out there called Open API. And there's a link in the resources about that, but that has really become, you know, kind of the standard of REST APIs. It used to be called Swagger, but now it's Open API, and there's a full open source initiative around that specification. And it's really neat. You can also provide examples in there and specify your models. So this specification really drives you to make sure you document all the technical bits of your API. And here's an example of what you could generate from that, because the specification is in either JSON or YAML, but then you can run it through this web application, and it can generate this really nice way to allow users to explore your API. They can come in and authorize their credentials, and then click on one of these actions and actually execute it in this interface, which is really handy. So that's one that's an absolute must for APIs. You have to have specifications to help developers who may want to interface with your product. And then lastly, but just as important in terms of documentation, is getting started guides. You know, introduce your audience, and this is for all of your audiences to know what your API is, what it's trying to do, etc. So introduce it. I can't tell you, every time you go to an API, I think it is pretty much the standard now that you see a getting started guide. You know, getting started is probably the most important thing for APIs, because usually someone is trying to solve a problem and they're trying to look at if your API fits that. So a getting started guide where they can kind of kick the tires of your API in the first 5 minutes is huge. And the last is guides and use cases. Guides and use cases are kind of lumped together, but most of the time when outside developers are trying to interface with your API if they have a specific use case. And having guides walk the user through that is huge to show them how to interact with your API. I've got a couple of examples from Twilio. One example here is a quick start. So this would be kind of the equivalent of getting started. Here's the steps you need to do, and it'll walk you through how to do that, which is really cool. And then an example of a guide or reference. Here's a guide on how to, build a server, how to build server notifications with Twilio's SMS. Again, a nice tutorial that could walk someone through how to do that step by step, which is great. So those are kind of the key points of documentation. That's what we want to use as our baseline for APIs. And then the next piece I want to talk about is validation. And validation really isn't mentioned a lot, and maybe it's just assumed, which would be great, but I want to emphasize it because a lot of times you don't see things in learning materials when building servers and APIs. You don't see a lot out there about validation because, again, it's not super entertaining, and it does take a lot of time to think through getting your right models put together so that you can create a valid schema. But when you think about it, you're moving from the browser or mobile phone over an HTTPS protocol. So you're moving from this unsecured kind of area to a very secure area. And what you want to do is, as soon as data gets into your secure area and you've validated the user, you've validated the scopes, you want to validate the data. Do not trust the data coming from the client, and do not wait until you try to put it into your database to trust it coming in. It just doesn't, it can cause some challenges from a security perspective, but it also can cause a huge challenge with troubleshooting, right? Because you're assuming that the data is going to be X and Y, and it's Z and F. The other thing is to do that, take advantage of some open source validation libraries. These libraries allow you to be super concise, and they're very easy to use. There's a structure called Json Schema that is more language agnostic, but if you're using JavaScript, I would recommend checking out some of these examples. Zod is fairly new, but it integrates with JavaScript and TypeScript and gives you a way to not only create validations, but also create types. Joy is a little bit older. It originated from the Happy project, but it's very robust and has been a mainstay in Node. Finally, there is Yup. And Yup works for both the browser and the server. So that may be something that you want to review if you need to share your schema between your browser and server and you only want to do it once. There's also some cool tools that will actually generate documentation from your schema validation. So you can actually put your schema and have it generate the Swagger docs so that when you change it, you're changing it in one place and you're keeping everything up to date, which is really cool. Here's a little example of a Zod schema, and hopefully it's pretty straightforward to follow, but basically we have this movie schema and it's an object. And then within that object, there's three properties: title, description, and year. And with the title, what we're doing is we're narrowing the validation to say, you know what, the title can't be greater than 200. And we can add modifiers on here to say that it has to all be uppercase, or it could have some custom regex. So we can, with a schema, we can really get narrow with what our data should represent. And the more narrow we can get without, causing unexpected pushback is huge, right? So for example, a year, we could say it's a string, but it might need to be numbers in that string. And it may only can be either a minimum of 4 and a maximum of 4. So it can only be 4 numbers. And with that, you can really prevent bad data from getting into your database or your cache or whatever. And you still want to be specific on those areas, but when it's coming into your API and you might be doing calculations on these things before you get to your database, you want to make sure that you just don't trust the data. And if it's not what you want it to be, you kick it out and you give that out. And then at the end here, when we're validating it, we just call safe parse and pass in our data. And if it's success, the success variable will be true. Data will be set. If it's a failure, the error value will have all the errors listed in it. So it's very easy to check. And then we have another topic that's not talked about very much is validate output. Validate output is something that I think if you're able to validate your output from moving from your API to the client, you're going to get a lot more signal when things go wrong, and you'll be able to find the problem quickly. Oftentimes with boundaries, right? When you have a boundary between one or the other and a problem occurs, it may not necessarily be super obvious where it occurred. So by providing validation on output, you can quickly drill down to eliminate certain boundaries. Like, this is not happening in my presentation layer. It must be happening from my application layer to my service layer, and I can quickly identify and reproduce it. Watching the Q&A, and George has asked about an example of a well-written API project, and there are many. If you're looking at products, I would look at Stripe, Twilio are great products. And then as far as open source projects, I would look at, I'm trying to think, I'll come back to that. I don't want to plug my own project, hyper63, but that's one you could look at and ask questions. It's not perfect, but we're trying. And I'd be happy to talk to you about that. But there's several open source projects out there that do a really good job. I think Express.js is one worth looking at, a server framework with an API, and I'll mention some more later. So with that, we're jumping into testing. And testing is very important. I think everyone should understand the benefits of testing. If you're able to get data to catch bugs before they reach your end users, that's a good thing. In terms of an API, testing, will talk about integration testing. And I kind of loop testing into 3 common buckets. You have kind of unit testing, where you're testing the specific code and you don't want to test anything else but that code. And then you have end-to-end testing, where you're simulating a user and you're actually pretending to be a user, and you log in, you click on this screen, and it takes you to the next screen, and then you click on that, takes you to a form, and then you key in elements of the form, and then you submit. So end-to-end testing is testing from a simulated user all the way to your service. Integration testing is a little different. And one of the things about end-to-end testing is it can be brittle. It can break if there's a lot of changes to your application. And it can be, kind of, even though they're getting better, it can be a challenge to get set up and run. Whereas integration testing kind of meets in the middle. So instead of a unit test or an end-to-end test, you're kind of capturing the test process at the request level, and you're going to the input, but then, and this is kind of an optional, you can actually go to a test service, or you can actually mock between your API to your service layer. And by mocking between your API and service layer, that means that when you run these tests in an automated way, they can run much faster because they're not having to build up the services and tear down the services when they're done. So an integration test kind of creates this bridge between the actual request and this mock on the end, where you actually return what the service would say. And there's a lot of benefits to doing all the testing, but I've found that integration testing really can hit a lot of pain points very quickly. And here's an example of a test server. And what we're doing is spinning up this test server, and we're attaching our app to it here. And when we do that behind the scenes, we're actually launching a web server that serves that app on a dynamic port. And then when we make our test call, where we're doing a fetch, we just call server.url, and that will be the URL and the port. And that allows me to run multiple tests in isolation. So they're not stepping on each other or sharing the same code. They're actually running independent threads. And that gives you high signal. So when something breaks, it's very specific. And then on the mocking side, here's some code to kind of show an example of that. When you mock a backend, in this case, we're mocking an HTTP service, and we're using a tool called fetch mock. And basically what it does is it replaces the current fetch API for API, but then we create this mock call and say, okay, when you call example.com, just return a 200, so that when your test runs, it doesn't actually go out, but all your code thinks it did go out and actually return. And you can test from your test server to your mock, all the code that's integrated within your application to make sure that it works well. And then when you're done, you can just restore, and that'll switch it back to regular fetch, so that you can have a highly isolated environment, which is pretty cool. And then the last piece about testing is automate your test. I believe there's a talk on GitHub Actions today, and GitLab has a CI. There's all kinds of continuous integrations and continuous delivery solutions. Find one and use it, because it will keep you up at night if your code, when someone checks it in, is not running test. And it hasn't been easier to add CI/CD to projects today. This is an example of a GitHub action, and you can see that it's probably about 15 lines of YAML, and you're checking out your code, you're pulling a Ubuntu instance of Node.js, and then you're running your application using a command yarn to install all your dependencies, and then yarn test. And that could be npm install and npm test as well. But putting this in your project as soon as possible will save you a lot of time. Okay, so the last topic we want to talk about is monitoring. And monitoring is one of those things that you really need, especially when you're trying to troubleshoot or trying to see what's going on. Earlier in my career, it really saved us from spending a lot of time of trying to identify issues we couldn't control. Like in the infancy of the internet, there was a lot of latency, or sometimes certain regions would go down, and we would have users call us up and say that your site is slow. And we would be able to look at these monitoring tools and see that the bottleneck was not actually with our servers, it was actually with their ISP or with a particular challenge in the region. So that's super helpful. Having the ability to observe or monitor in your application can really make good use of your time when you're trying to track down problems. And there's two, general areas of monitoring, and that's APMs, or application performance management. And that's where you actually download a little module in your application and inject it into your application, usually in the form of middleware or something like that. And it will run in your application alongside and record the processes that are going through, like how much memory each call is using, or how much CPU, or what's the response time. And those are kind of the core metrics, but then you can also create custom metrics with application performance management, and it will give you a nice dashboard. One example that I mentioned in the resources is Prometheus. Prometheus is a great tool that's open source that allows you to do this. And when you pair it with Grafana, then you get, and Grafana is a visualization tool. So you're able to get a good visualization of what's going on. And those are some great open source projects. Also, Elastic, the company behind Elasticsearch, has an application performance management product. And then there's several commercial products out there, like Sentry is super popular, and New Relic or LogRocket, and others. So application performance management is pretty easy to put into your code. You may spend a little time, kind of configuring Prometheus and setting up Grafana, but there's some great tutorials on how to do that. And then the other one is log aggregation. So every API has the ability to log to the standard out, and then you can actually aggregate those logs and throw them into a data store. And Elastic has a great product called the Elk Stack, which stands for Elasticsearch, Logstash, and Kibana. And you can load the Elk Stack in your data center, and then it can go and pull these logs from an aggregate process and generate these huge dashboard displays that can give you a lot of insight into your application from the logging aspect. And what's nice about this is you could have, let's say you have a microservice architecture where you may have several APIs all running in different kind of servers, and you can pull them all together and see them under one nice view and run some analytics on it, even apply some AI to identify patterns and things like that. So logging is huge. There is an open source library I mentioned for JavaScript that's really nice, called Pino, P-I-N-O. and it gives you kind of the ability to log.info or log.error, etc. And you can, you know, kind of fine tune what you want to show in each environment, like show me all the debug statements or show me just errors, etc. So that's kind of cool.
Tom, I just wanted
Yep.
to give you a friendly reminder. You have about 2 minutes left.
Thanks. Perfect timing. So looks like time's up. And I know I probably went pretty fast, but wanted to cover all of these things. So I'll wrap up just to recap. Again, there's 5 important things to think about when you're, you know, building an API, and that's security, HTTPS, SSL certificates, authentication, authorization, documentation, your README, your technical specifications with Swagger docs, and getting started in guides and use cases. Then validation, validate at your points or your boundaries, right? So a boundary is between your client and your server, between your server and your services. Do the validation there, both in and out, and it will save you a lot of pain. Trust me, I speak from experience. And testing is huge. It's easier to test now more than ever before. Use CI to test and automate your tests. And then finally, monitoring, right? Use application performance monitoring. It's your friend. Some other things to look at quickly is versioning. Once you hit these 5 requirements, you may want to have a strategy on versioning. Again, that can get kind of challenging, but when you do versions, you have to commit to having multiple versions in production, and you want to manage that properly and appropriately. API management, if you want to monetize APIs, definitely take a look at API management. And finally, microservice management. Those are some great things as well. And so here is a link to some resources in a gist, and this is a short code link, and I'll be posting the slides where Jennifer tells me, so these slides will be available today, but if you want, I can paste this link, I think, in the chat. And do I have any time for questions, Jennifer?
We are unfortunately out of time. So
well, I will be around at the hyper63 booth if anyone has any questions. And my Twitter is at twilson63. So please send me a tweet or hit me up in the conference room.